Hello and welcome to the latest episode of How to Code a Game Like Minecraft in Unity. In this episode we're going to be tackling lighting, or at least the beginning of lighting. There's going to be quite a few steps to this. We're not going to get all through it all in one video. Basically, we've got what we're going to do in this video, which is sort of the foundation for the lighting, and then we get to basic lighting, and then I'm not quite sure whether there's two parts to the Minecraft lighting. There's the global illumination, the sun essentially, and the moon, and then there's other things like torches and glowstone blocks and all that kind of thing. They're two separate things. I'm not sure if I can squeeze them into the same video or not. And then obviously this smooth lighting, fancy lighting, or whatever it is that Minecraft calls it. In this video, we're going to be writing our own shader, which I won't lie, I am by no means qualified to be telling you how to write a shader. I have literally just learnt enough to be able to do what we're going to do in this video. So unfortunately, if you have any shader related problems, I'm probably not going to be able to be of much help unless it's specifically what I've covered in this video. But anyway, let's get started. So the first thing we need to do, I know a couple of you pointed this out in the comments. I'm sorry I can't remember any specific names. The weird effect that we get in the trees, in the leaves specifically, where it looks a bit odd there, is the result of using a transparent shader. So if you remember, if we go into our chunk script, we set up this system whereby we use two separate meshes inside our chunk. So we have a transparent and a non-transparent, and then we're using a fully transparent material shader on the transparent one, which is what's causing that weird effect. It's not really set up, it's not really meant for that. And a few of you pointed out that none of this was necessary. You could just use transparent cutout, which is true. I thought I explained in the video when we did this why I did this, but I went back and watched it, and either I imagined that I explained it or I edited it out for some reason, so I apologize for that. Basically, we are going to need this setup, not for the transparent stuff, for things like water, and if you ever wanted to have, say, swaying leaves and grass that sway in the wind, you would need a separate mesh for that. Basically, anytime we need a separate shader, you're going to need this setup with the different triangles. However, for simple transparency, we don't need it. Rather than keep this here for now, because it's just going to complicate issues, we will get rid of it for this video, but just bear in mind that it will be coming back at some point, probably when we do water. So for now, we'll just comment this stuff out, and then up here we want to scrap this, and we just set the single material equals world.material, and then if we go back down to here, create mesh, we don't need to set the sub count. We're only going to be using one mesh for now. We don't need those, and we just say mesh dot triangles equals triangles.toArray. So now if we run our script, we can see the weird effect has gone on the leaves, but also so has our transparency, which was why we did all that in the first place. Now, as I said, as pointed out in the comments, you can just set this, instead of unlit texture, you can set it to transparent cutout, which should cure it. There we go, we've got our transparency back, and we no longer have the weird effect on the leaves. However, the problem with that is we can't do what we need to do for the lighting using this transparent cutout shader. So we're going to write our own. So if we go into our scripts folder, brace yourselves, we'll go up to shader, and it doesn't really matter which one because we're going to be starting completely from scratch, so just pick unlit shader, and we're going to call it standard block shader, and open that up. So for those of you who've not played around with this is a completely different language. Well, it's not, I think it's got roots in C, but it's basically a different language. So I'm going to try and go through it with you as we create the shader, but like I say, bear in mind I only taught myself enough to be able to do what we're going to do, so I am not an expert at what's going on here, and I don't fully understand everything that is happening. But the first thing, which is fairly straightforward, is we need to tell it what it's called. So we're gonna put it in Minecraft blocks, and this is just where it appears in the menu, and obviously it's a shader. The next thing we need is a properties block. If I just pull up another shader, like blocks for now, properties block is this stuff here. So right now, alpha cutoff, that's a property. Base RGB trans A, that's a property. We don't need this alpha cutoff part, but we do need a base texture. We need to be able to give it our blocks. So to do that, we're going to type underscore main text, which is obviously main texture. And then in the brackets, we give it a name, which we're just going to say block texture atlas. We need to tell it that it is of type 2D, and then we need to tell it its default color state. That wants to be outside of the quotation marks. So that's going to be it for now for our property block. And the next one is the subshader. And now we're starting to get into the region where I don't quite understand what's going on. So first, we need some tags. Now, the tags basically tell the graphics card what it's doing, like what kind of shader this is. We need Q equals alpha test, ignore projector equals true, and then finally render type equals transparent cutout. Load 100, which is your level of detail. And then we want lighting off because we are creating our own lighting. The next thing that we do is we create a pass. Now, a pass is like one pass over the screen, if you can imagine it. We go over the scene, find what pixels we want to put them on the screen, and we do something to them. You can have multiple passes, but bearing in mind that each pass that you add to your shader will increase the amount of time, because it's basically kind of like drawing the screen multiple times, which is essential for some things, but we're only going to need one pass for what we're doing. So the first thing we need to type in our pass is CG program, and then we need to include some function types. Again, I really shouldn't be trying to explain this as I go because I am not entirely sure where it all does, but we need a vertex function, which we're going to call vert function. We need a fragment function, which we will just call frag function. And I think we need target 2.0. I think that's the compiler version. Again, could be wrong. We need to include unity cg.cg inc, which seems fairly self-explanatory. It's including some unity functions and whatnot. Now we need to create a struct, and this struct is going to be called appdata. In this appdata, this is essentially pulling the information from our geometry. So, well, for example, first we're going to use a float for, which we're going to call vertex, and we're going to be putting in that float for position. So this is a predefined value. Basically, it's getting the position of the current vertex that we're looking at. And then we need our texture coordinate for the current, or pixel, not vertex, sorry, the current pixel that we're looking at. So we need our texture coordinates. And the 0 is because you can have more than one texture, and that is pulling it from our raw geometry and putting it in there. However, we need another one, another struct, which, because in every tutorial or anything I've looked at is called v2f, I'm going to call it v2f. I don't know if that's a crucial thing or just what everybody calls it, but I'm not going to stray from what appears to be convention. And then in here, basically, we're pulling the same thing. So vertex, only this time we want SV position. And then we're going to get another UV, and this one is going to be exactly the same. I spelled all that correctly. The other thing about writing shaders is that Unity isn't great. It seems to be better at telling you when there's a problem, but I know for a while you didn't get any sort of error reporting on shaders. It just didn't work. Outside of our structs, we need to declare some variables. The first one is sampler 2D, which is basically texture 2D as best I can tell. That is it for now, right? Appdata was populated inherently by this pass, essentially. So it's looking at a pixel, it's getting the necessary vertex and UV information, and it automatically populates appdata. However, this v2f we need to populate. So v2f vert function, which is this up here, and we're going to pass in appdata. So in our v2f vert function, we're going to create a new v2f element instance or something, which we're just going to call O. I've also seen them called out in all caps. And then we say O.vertex equals unity object to clip pos v.vertex. So unity object to clip pos converts the point in world space to what it needs to be on the screen. kind of like a transformation. It transforms it from 3D space to the 2D space of the camera. And the v.vertex is we are getting this value here out of app data. And then we also need UV coordinate, which is a much more simple. We just give it the UV coordinate straight out of our app data struct. And then we return not 0, O. And then once we finish that, we need what will be the last sort of block of code in this shader. We're by no means done with this shader, but this is the last sort of block. Fixed for, which is a data type. Basically, think of it as like a quaternion. It's 4 values. Frag function, again, now we're getting this one here. And this one is going to take in the v2f that we have just created here. And we're going to call that I. So the first thing we want to do in here is say fixed for col. So this is creating col as in color. This is creating a new color variable. Things like vector3, color, all that, they're sort of unit specific things. Shader language, HLSL I think it's called, does not have any of that. So we're going to say fixed for col equals text 2D, and then we're going to pass in main text, which is the texture obviously, and then I.uv. And then all we have to do after that is return col. And then outside of here, we say end CG. So that's, we started CG program up here, and we're ending it here. If we just go into Unity and see if it's giving us any errors, of course it is. Sorry, we need semicolons on the end of these. And what have we got here? Oh, okay. Yep, these are a float 4 and a float 2, not a single float. Okay. Right, so we've got rid of all our errors. So let's just try, if we go find our material, find our blocks material, head up to the top here, we have this Minecraft subcategory now, and we have blocks. Okay, well we have it's not bright pink, which is a good sign, but what does it do when we press play? Right, so this is now running on a shader that we wrote. Now as you can see, there's no transparency, but we haven't told it how to deal with transparency yet. So let's do that next. So if we go down to here, we're going to have to mess with this value a little bit. There's going to be a lot of messing with this value a little bit. So for now, it's quite simple. We're going to use a function called clip. So clip, basically, it does a check on whatever I put in these brackets here. And if that value is less than 0, it just scraps this pixel altogether. So it's, as far as I know, it's best to have this as early as you can, because if you're going to scrap a pixel, you don't want to waste time like working it out. So the earlier you can scrap it, the better. So this is about as early as we can scrap it. We can't scrap it before this line because we need this value to know whether we're going to scrap it or not. So all we're going to do is we're going to check col.a, which is the alpha value of this color, the transparency, -1. So if a is anything other than 1, it's like 0.9, 0.5, 0, this value is going to return less than 0, in which case it's going to get scrapped. So now if we go back to here and try that again, as you can already see in the preview, we're not seeing a whole sphere full of bright colors anymore. And now we have our transparency back. And we don't have that weird effect on the leaves. And if I pull some glass out, nope, they're leaves, aren't they? If I pull some glass out, hopefully, yep, glass works too. Great. So, we're back to where we started at the start of this video, but now we can do lighting. And to do that, what we're going to do is we go down to where we've just added our clip function, and we're going to add another modifier to it. So after the clip function, because as I said, you want that out of the way as early as possible. You don't want to be calculating things on a pixel you're not keeping. So we'll say col equals lerp, and this is exactly the same as how lerp works in regular Unity C#. Col is the first value, and we're going to create a new float for the second value, which is going to be 0, 0, 0, 1. Now what this, sorry, that float for, not float. What this this is an RGB color. So this is your red, green, blue, and then the transparency. So this is black, basically, solid black, transparent. And then we're going to pass in a value, which for now, this is between 0 and 1. So 0 will be fully the color, and 1 will be fully this float 4, which is black. So if I put in 1, I break it. Oh, sorry, yeah, you don't put the F for floats in shader language, and you do put the semicolon in. So if I run this now, we should have nothing but blackness. Yay! It's very dark. However, if I change it to 0. Let's say 5 and run it again, we can see everything's just a bit darker. So this is essentially global illumination. This is how we're going to achieve our lighting, is we're going to tell the shader to tint all of our pixels by an amount. However, we can't be hard coding the amount into our shader because it just won't work. From the main code, we need to be telling the shader what amount we want. So the way we're going to do that is if we go back to where we declared our texture, and we're going to declare a float, which we're going to call global light level. And then that is the value that we're going to put in here. And then we're going to go into our world script, wherever that is. And we're going to create some new values. So we'll just stick them here for now. So a public float global light level, and we're going to stick a range on this. Range. So it needs to be backwards from, because 1, if you remember, 1 is all the way black and 0 is all the way like light, the color. So we're going to put this backwards. So it wants to be 1F and 0, so we're sliding left to right, left being darkest, right being lightest. Actually, however, we don't want it to be 1F because that would be complete pitch blackness, and Minecraft is never completely pitch black, so let's just stick it at 95F. And then if we go down to our update, and this is temporary, by the way, this is just to show everything working. We're going to get into how we specifically do this in a later video once we've got the lighting set and completely done. But for now, we can use this cool little function called shader.set global float. And we give it the name of the float, which we need to get right. Global light level. Just copy that. Global light level. And we are going to give it the global light level. Now what this does, this set global float, is it basically broadcasts to all the shaders that are running in the scene, and if any of them have this value, it sets it to that value. So if you start messing around with this sort of setup, if you have 2 shaders, don't give them the same value variables unless you want those variables to work together. So if I had a separate shader with a global light value that was different, this would still set that global light level, like even though it's a separate shader. So it's basically any shaders running that have a variable with this name will be set by this line here. So just bear that in mind if you start playing with this. So if we go to world now, we have this global light level here. So if we just take maximize on play off and hit play, and then we go over to our global light level, and we can see it gets darker. And it's not getting completely dark because we've clamped it to 0.95. So we're on our way. So we can now set at the light level, the global light level, from outside of the shader. So let's just quickly, for the sake of appearance, let's just quickly make a few changes. We'll get rid of directional light because we haven't been using that directional light since, I don't know, never really. I don't think we've used it once in this tutorial series. I want to go into rendering, lighting settings. We want to set our skybox to none. We want to set our, well, I don't think the environment lighting makes any difference, but we'll just set that to color anyway. Ambient mode, doesn't really matter. Basically, we want all these to be the minimal, whatever is going to use the least processing power, because we're not using any of it. So we don't want real-time lighting, and we'll get rid of that. Then if you go into your camera, we want to set this to solid color. And then for the color, we're not going to set that here. What we're going to do is we're going to go into our world, and we're going to create 2 public colors. Public color day and public color night. And then if we go to that world script, our day color will just make some garishly bright blue thing. It does, like, this is just for demonstration purposes. It's not actually what we're going to use. And then for nighttime, we don't want it to be pitch black because that will just make it difficult to see. And we don't want it to be a lighter shade of black because then it will just look like the whole screen is dimming. There needs to be some contrast between the actual terrain and the sky. So we're going to make it a sort of dark blue color. And then back in our world script, Again, remember this is just temporary code, so this is why it doesn't look very optimized. We're going to say camera.main.background color equals, and again, I would never use this camera.main in an update loop. If this wasn't just temporary, just to show you some stuff, I would be caching that somewhere in the start. Color.lerp, and then we say day, night, and the amount is global light level. So now, if we hopefully run it, we can see we have that horrible garish blue. But if we make it nighttime, it goes dark. You can have that be a different shade or whatever. We'd be putting skyboxes in before any sort of finished game, but it makes it look like nighttime. So that's global illumination. I'm just going to very quickly, even though we're not doing it in this video, we're just going to very quickly touch on shadows, kind of-ish. Now, to get individual block shadows, I mean, obviously, we could modify the texture as it's being set in the chunk, but that would be incredibly inefficient and it'd be a bit pointless given that we can use the shader, which is much better at this kind of thing. But in order to do that, we need to pass in data to the shader, which is tricky. So the way we're going to do it is there is another value that we can get out of our app data, and that value is a vertex color. So we say float for color, and then we want the same thing in fact, I'll just copy that line. We want the same thing in our v2f. And then in here, we'll say o.color equals v.color. And then here, we will create a new float, which we're going to call local light level, just for the sake of not really knowing anything better to call it. And this is going to equal the global light level plus i.color, I being the v2f that we created here. And then we will set this to local light level instead. So, oh, and the other thing is we need to clamp this. So if we just put clamp, and then we need to clamp it between 0 and 1. So that should be it for the shader, but obviously we need to give it a vertex color. So if you didn't know, a vertex can have a color assigned to it. So you can basically, you can color a model without giving it a texture by assigning vertex colors. So if I can just find the right part of this script. There, right. So actually I do need to go all the way up here. So we need a new list, like our triangles and our UVs and stuff. This one is going to be a list of colors, which we'll just call colors, equals new list color. And we need to remember to add it to our clear. So colors dot clear. And then when we get down to our update mesh data function, we want to modify our colors array list, our colors list. So let's say for now, float light level equals 0.2, we'll say. Let's say colors dot add new color, and then we're just gonna, it wants to be black, so that's not, and then we're gonna pass in the light level. However, we need to do this 4 times because there are 4 vertices. And we need to put enough brackets at the end there. So now, if we run that... Actually, I'll just change this value to something a bit higher, just so it's more obvious. And we need to set it, obviously. So mesh.colors equals colors.toArray. And then finally, hopefully if we run this, we should have a dark scene, which we don't. Oh, right. I don't want to be passing in the whole color here. I just want to be passing in the alpha. So we're lerping between the global light level we're passing and the alpha level of the current vertex that we're looking at. So hopefully if I run that now, Yeah, as you can see, the blocks are shaded darker even though we are at maximum light level. And we're clamping it so it can get darker than 0.95, and the shader won't let it go lower than 0, which I don't think is possible anyway, but it won't let it go because it's clamped. But it can't go higher than 0.6 because or lower than 0.4, I guess it would be, because the vertex itself is carrying a light or a darkness level, would probably be a more accurate way of terming it. So the last thing we're going to do before we finish this video is we're going to get some sort of very basic shadows going. And it's very simple. All we're going to do for now, again, this is all temporary, just to show stuff working, is we are going to do a check on each voxel to see if there is anything above it. And if there's anything above it, then we're going to put a shadow there. And if not, we're just going to leave it. So we don't need to set the value yet. We're going to set the value afterwards. We need a new int ypos, which is going to equal the current position of this block that we're looking at, plus 1. So we start in one block above whatever we're looking at. We need a bool to check, are we in shade, which is going to be false by default. And then we're going to say while ypos is less than voxel data dot chunk height. And then just straight away at the bottom, I'm going to type ypos++ just so that we don't forget, because we're using a while loop. If we don't increment that value, this will just loop forever and Unity will hang and there'll be no way out other than, you know, Control Alt deleting or restarting your system or whatever. So inside here, we're just going to say if voxel map, and we want, you know what, let's just copy this from up here. Again, this is all temporary. We'll come up with a more efficient way of doing it in the fullness of time. So we're saying if voxel map at this position, ypos, so not moving on the X, not moving on the Z, but we're basically incrementing upwards from whatever position we're on. If it does not equal 0, so it's not an air block, then we say in shade equals true, and then we'll break out of the while loop. Otherwise, it will get all the way to the top. It will say, once it hits this condition, voxel ypos hits voxel data.chunk height, then it will break out of the while loop itself with in shade equaling false. It will only be set to true if we encounter a block above where we're looking. So, once we get out of that, we do a quick check. If in shade, then light level equals, we're going to say 0.4. So this is shade, remember. The higher this number, the darker it is. And then we'll say else light level equals 0. So now, if we run this, we have shadows, kind of. And obviously, this was a very rough test. This isn't supposed to look perfect. Obviously, Minecraft has a bit more to it than that, but as you can see, the shadows do update because they are working from the shader. And you can make the shadows darker by increasing this value. If I set that to 0.8, they're going to be very dark shadows. They're much darker shadows. And of course, if I make it darker, the shadows are the first thing to get dark, but they are clamped, so they can't get darker than, well, 0. They can't get darker than black. And we can put a check in to, like, not make these blocks, the leaves, shadowed. All it is it's checking if anything's above it, and if there is anything above it, then it's making it a shadowy block. Obviously, we don't want these shadowed, but that is a more complex check that we will need to do at a later date. For now, we've got this working. I'll just set this back to 4 no, we'll go with 5. So for now, we have basic lighting sort of working, and we can make it darker, like daytime and nighttime and whatnot. And that's it for now. So in the next video, we will get, I think Minecraft calls it flood lighting going. That is where, say, here would be lighter because there is a light block next to it, or a lit up block next to it, and then the more into the shade you get, the darker it gets. That requires quite a bit more Well, more regular code anyway. So we will get into that in the next Minecraft video. I hope this one wasn't too much of a slog. It felt like a slog to record. But yeah, that's it for now. Let me know what you think. Like, if you like the video, like and subscribe. And we will continue on with our lighting tutorial next time. Bye-bye.